So now we're going to find the equation of our tangent for this equation here when our value of x is going to be equal to 5. Well, we're going to be finding the tangent, so our equation for the tangent is given by y is equal to the derivative at our value of x outside of x minus our value of x plus our function evaluated at x. So our first step, we'll find out what our function of x is. So what our g of 5 is going to be. Well, it's going to be 1 over 4, 5 cubed, minus 2 outside of 5 squared, plus 4 times 5. Solving this one out, we get 5 cubed, which is 125, over 4, minus 5 squared, which is 25, times by 2, which is going to be 50, plus 4 times 5, well, 4 times 5 is 20. So our next point is, well, this part here, minus 50 plus 20, well, that's going to give us minus 30. Now we need a common denominator again. So 4 is there, so we'll times 30 by 4. 3 times 4 is equal to 12, so that's going to be minus 120 on 4. Putting that out, we get 125 on 4 minus 120 on 4, which is going to give us 5 on 4. So our function, when it is evaluated at 5, is going to give us an answer of 5 over 4. So that gives us our function value at our point. Now we need to find the derivative of our function at that point. Now, because we've only got polynomials in the function, we can use our differentiation rule. So when our function is in the form of kx to the n, we can use our differentiation of our derivative f prime of x. It's equal to kn x to the n minus 1. Now we just need to find the derivative, so our g prime of x. Well, that's going to give us 1 over 4. The 3 is going to come down, so we get 3x to the 3 minus 1. Next we have our minus 2, so minus 2, our 2 up here comes down, so that's times 2x, now the 2 minus 1, plus 4. We have a 1 up here, so we'll bring that down, times by 1, x to the 1 minus 1. Now let's just simplify some of this. What we've got is 3 times 1 over 4, so that gives us 3 over 4. X to the 3 minus 1 is 2. Minus 2 times 2 is 4. X to the 2 minus 1 is 1, so we just leave it as x. Plus 4, x to the 1 minus 1 is 0, and that is just equal to 1, so it just is plus 4. So this is our equation for our derivative of our g of x. Now we just need to solve our g prime of 5, which is going to give us 3 over 4, 5 squared, minus 4 times 5, plus 4. So 5 squared is 25, 25 times 3 over 4, minus 4 times 5 is 20, plus 4. So then we've got 75 on 4, minus 20 plus 4, minus 20 plus 4 is going to give us 16. So now we need to times our 16 by 4. So 16 times 4 is going to give us 64. And we make sure that we put that over 4. So our equation is 75 on 4 minus 64 on 4, which is going to give us 11 on 4. Now we have our derivative evaluated at that point. We can go ahead and solve our equation for the tangent. So our equation is going to give us y is equal to our derivative at that point, which was 11/4. Then we have our x minus 5 from our original point, plus our function value at that point, which we calculated as being 5/4. Next, we just expand it out, so we get 11/4x minus 55/4 plus 5/4. To make things neater, we're going to times everything on this side by 4 and everything on this side by 4. So that gives us 4y is equal to 11x minus 55 plus 5. 55 plus 5 is going to give us minus 50. So our equation is going to be 4y is equal to 11x minus 50, and that's our equation for our tangent at the point x equals 5. So let's have a look at that on the graph. Our red line here is our original function, so our 1/4x cubed minus 2x squared plus 4x is this red line here. And our tangent, which is given by our 4y is equal to 11x minus 50, is given by this orange line here when our value of x is equal to 5. So that's the point where it touches here.